Okay, so we are a collaboration, and so I cannot take credit for all the things that you're going to see. I actually came on board at the collaboration about 2 years in, at the point where they had kind of like, there was a first setup, and they were like, how can we do better? So I'm going to tell you a little bit about how things started, and also some of the lessons that we learned along the way. And I hope that they'll be sort of generally helpful in terms of thinking about even smaller collaborations. Okay, so here's where we are in the schema. So the question is, how can a group of this size possibly work together? So we have a lot of examples of single PI labs, right? In this room alone, probably many people run their labs differently, and they're all successful. But when we combine across labs who have different approaches, that variability can be challenging. You can imagine that in some labs, what contributions are required for authorship, or whether people are expected to work weekends. All of those things may differ, and suddenly you have to find a way to work together. And so I'm going to tell you about some of the best practices we learned the hard way. Okay, so this is just, it's not so important the detail. I just want to give you a sense for how we organized ourselves. So we had a general assembly, which made all of the big decisions. Oh, and I should say that we call this the flattened hierarchy. It was actually modeled after the Atlas collaboration at CERN. We did not, I'll say many times, we did not make up anything ourselves. We love open science, and we tried to find models wherever we could that would work for us and try and adapt them. So that's this flattened hierarchy. In the original version, the General Assembly was actually entirely PIs. It was all the PIs in the organization. Then we had working groups for streamlined daily operations and decision-making. And you can see that the working group chair, which was typically a PI, reported into the executive board. There was an associate chair who also had a leadership place in this organization. And that was often a staff member or a researcher, a trainee. And then there's communication across all of these areas. And so the idea is that information is being shared up and down and across. And so this helps us, even though we're a very large organization, have mechanisms for communicating broadly. But we learned pretty fast that this was like not the perfect thing for us. We still needed to make some modifications. So this is a little later. You can see that one of the first modifications we made is that the researchers and the staff said, hey, wait a second, the General Assembly is all PIs, and they're making decisions that affect the entire organization. We should have a voice too. And so we added a researcher representative who's elected among the researchers, and a staff representative who's elected among the staff. We also found that over time, the staff took on more leadership positions in the working groups, because particularly for working groups that had technical scope, as they were doing a lot of the work on that. And then finally, we had to write papers together. That was also tricky. And so we created something called a task force, which was another way of bringing people together to take on a task. Okay. So the question is, like, how do we make decisions? People ask me that a lot. Like, how on earth? 20 PIs talk about cat herding, and a researcher representative and a staff representative. Here we leaned on sociocracy as a mechanism. And the idea here is that anyone can have a good idea about how things might change or what you might want the organization to do. And then they and whether other stakeholders, or in our case, a working group, might come up with a proposal for what change you want to see. Everyone discusses that, though. That's sort of made public within the organization so that everybody has an opportunity to give feedback. And then the General Assembly, as I said, makes the decision. But I want to highlight here that this decision is not like an up or down vote. We use a process of consent where everyone has to agree that whatever the option is, it's good enough for now and safe enough to try. Because I think the idea that you would ever get 20 PIs to say this is like my first choice we'd never have gotten anywhere, for sure. Okay, so it is possible to object, right? It might not be your first choice, but you might also really be worried that that the policy would harm the organization, and in that case, you make an objection. And if that happens, we go back through and we discuss, we make changes, and then hopefully we come to consent, and then you have a policy. And sort of that's the general process that we used at all levels for making decisions in the organization. No, so the way it is run as a poll, but basically what happens is you get a poll, and the poll says, I consent with concern, so there might be some things I don't quite agree with, or I object. And then basically we look at those answers, and as long as we have a quorum of people who consent or consent with concern, so we have to make changes, and no objections, then we move forward. Okay, but now, so I've laid out, what's that?
To that, there's a norm that if you object to something, you are basically taking responsibility for making it work, which means the objections are fairly rare.
Indeed. Okay, so now I've laid out for you. We have a structure. We have a decision-making process. So, but we actually had to get going, right? We had to start recording. And so the question is, how do we do that? Because we wanted to set clear expectations in advance, right? I think that's really important for making an organization work well. But none of us had done this before, right? So we didn't really know. So we made, again, what was our good enough for now, safe enough to try approach. And I just want to give some examples. So even something as simple as onboarding really required an organized plan, right? It may be that in your lab, there's a senior postdoc who knows what's going on, and you can always tap somebody on the shoulder and say, hey, do you know where to find this? We had a lot of institutional knowledge that was distributed widely across the network, and we really needed to think hard about how we were going to make sure that people, as they came on board, had access to that. In particular, where to go look for things when they needed to find them. Some other areas where we have formal policies are conflict resolution and ethical behavior, authorship and credit assignment, which you can imagine is pretty sticky, data release and sharing. So one of our main missions is data release and sharing, and we wanted to make sure that everybody was clear about what our expectations were, so that we could clearly be sharing. And we have on our website, you can see all of our things. And I just, as an aside, I think that all labs could benefit from having clarifying norms and expectations going forward. I don't think this is a problem only of a 70-person collaboration. And finally, again, I hope this theme that policies should be updated regularly comes through. Okay, so adapting our ways of working. So we did notice that although in principle anybody can put forward a new policy or have an idea for a new policy, the reality is that our researchers, our trainees, they live in the ecosystem, which is academic science, where there are power issues and power dynamics, and so not everybody may feel comfortable speaking up. So we initiated this annual survey, which allows us to get anonymous feedback about what's going on in the collaboration. And these results actually allow us to seed new proposals for change. And in the spirit of open science, this is actually based on a great tool by Leslie Vosshall, and it's super easy to deploy, and I think everyone can benefit from it. Okay, so another key piece of this was promoting career advancement for trainees. IBL trainees are unique, right? They have some experiences which separate them out on the job market. They have an expanded network. They have leadership opportunities in working groups and task forces. They get experience with team science, which I think only becomes more critical in the future. But of course, in team science, there's a real issue of credit assignment, right? We want to make sure that people recognize all the work that our trainees were doing. And that's complicated, particularly for papers. So, the two papers that Alex just talked about, they're going to be in Nature, but they are 30 or 40-person papers. How do we know who did what? So this is actually a credit assignment matrix from a previous paper where we talked about standardized behavior. But the goal here is that, on the left, you have all of the standard credit taxonomy categories, and then you can see basically pretty clearly, pretty quickly, there are 3 levels of contribution, where dark purple is I did a lot, and light purple is I did a little. And you can see that some people clearly did more and were more leaders of this paper than others. And hopefully it's a little bit more obvious than when you look at a paper and there's sort of one very, very long list of credit, of contributions. Okay, so the other piece of how we promoted career advancement was using individual scientific projects. These are the sort of more classic, generating first author papers. And our researchers had some pretty great advantages in terms of infrastructure for those projects. So they had early access to the brain-wide electrophysiology data set. And they also had, I think, super important, they had tools and technical support from the IBL research software engineers that really, I think, helped them to facilitate their work. Okay, so now you could ask, how well did that go? We finally have enough, enough of a cohort that has finished, and I'm happy to say that of the IBL postdoc alums, 11 are in tenure track positions, 4 are in another postdoc, 4 are in industry. You may recognize some of these. Fanny maybe is in the audience somewhere. And I think, so that means that 55% of IBL postdocs are now in tenure track positions, and as compared to the NIH average, that's certainly I think we should be proud of them and of the organization. And so I'm out of time, so I'm just going to say I hope that these themes kind of came through, and I hope that people take advantage of them because I think they improve the quality of the workplace for everyone. So thank you, and thank you to the many, 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 many people who were part of this.
Couple of questions.
So you didn't really talk about your role and how you sort of managed the group. So can you say something about that? I mean, did you set up these structures?
No.
It was all a collaborative effort.
It was all collaborative. I would say that in the end, there's some things that require someone to just get them done, right? Like somebody has to facilitate a discussion, or somebody has to, sort of pull together a lot of ideas and try and facilitate that. I think somebody has to help with communication. I think, so Gail Chapuis, who's the project manager back there, and I think sort of take the bigger view of the organization and spend a lot of time talking with lots of people and trying to provide a level of, I think, as much as we try and have everything documented, and there's still, I think, a sort of level of institutional knowledge that lives in people. And so I think both of us did quite a bit of that.
This is a little bit sticky, so you don't have to answer this if you don't want to. But how do you ensure quality control among the labs in behavior physiology or whatever? If you have labs who others feel like are underperforming, either in the quality of the data or the volume of the data, or failure to do what they've pledged to do, how do you, and that should have financial implications, presumably, about how funds get split up. How do you handle that?
I'm not sure how much I want to say about that. The one thing I will absolutely say is that quality control was really, really key, right? And Anna's going to talk this afternoon about how we actually figured out quality control, because maybe some lab is producing many, 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 many recordings, but like they're not particularly good quality, and maybe some other lab is has high quality but low quantity. And so so that was really important. So I think for us, a big piece of this was just having the metrics. And we didn't get to a place where we were like, we see that there's something that is so terrible here. So so I think we were lucky in that the metrics really helped us to solve that problem, and we sort of have a sense of it.
So 4 days a week I work at Meta Reality Labs in an applied science effort. This is the Control Labs EMG band, for those that know. And this is a 200-person organization that is working to build this thing. And in that organization, we have many, many roles that are not present in the academic environment. Technical program managers, product managers, dedicated software engineers, dedicated site engineers, and so on and so forth. And so my question is, my read of this talk was sort of very science-oriented, makes sense given the crowd. But I'm curious about these other roles, and did you miss them, or did you have them, or how did you facilitate that, et cetera, et cetera?
So we definitely had roles, staff roles. I didn't have time in this talk to go into detail, but Gail Chapuis is our technical project manager. We have a team of research software engineers who are it's a relatively flat team, so not quite the kind of hierarchy that you might have at Meta, but we're a small team, so so maybe not quite such a need at this moment.
So it's not turning red. I'm
confused. I thought there were a larger number of postdocs involved in this than you discussed at the end. And so did some of them drop out? Did some of them you didn't include, or
Not all of them are finished. So, so that was like what I think there were maybe 20, right? So the original, there were 20 labs. So there were like the first round of postdocs was about 20 postdocs.
only 20, only
yeah.
one postdoc per
So
lab.
it was roughly one postdoc
Yeah.
per lab. Some labs had a graduate student instead of a postdoc. So there's some variability, and then some postdocs are still working. They're not finished yet. So
I
that's
see.
like only our first cohort, really.
I see. Okay.
All right.
Thank you.
Thank you.